Okay, let's look at practice exam 3, problem number 8. Right. So we want to find all three critical numbers between 0 and 2 pi of this given function here. Right. So let's take the derivative since we're looking for critical numbers. Right. So f prime of x is equal to, right, 12 just a constant multiple, so I'll just put that there. Right, then derivative of cosine is negative sine of x. Right, then there's a 6, so I'll put 6 there. And derivative of cosine of 2x would be negative sine of 2x, and multiply by derivative of 2x, which is 2. So we have to use the chain rule there. All right. So then you pull out the common factor. In this case, you have negative 12 here. You have a negative 6 times 2 gives you negative 12. So we can pull out the negative 12. So you have negative 12 pulled out. And what's left is a sine of x. Then plus sine of 2x. Right, then we have to use one of those trig identities, and you can see that the sine of 2x is same thing as 2 sine of x times cosine of x. Right, so we can actually find another common factor. So sine of x from the first term and sine of x from the second term. All right, so we can pull out the sine of x as well. So you have negative 12 sine of x pulled out. And what's left is, so sine of x is pulled out. There's 1 left from the first term. So sine of x is pulled out, so there's going to be a 2 cosine of x left over, right? And so this is the derivative, so we want to set that equal to 0 so that we can find a critical number, right? So there are a couple of things that we can, possibilities we can think of. We can make sine of x equal to 0. So we look for the angle x, which makes sine 0. Right? And also here, 1 plus 2 cosine of x equal to 0. We can do that when cosine is negative 1/2. Right? We just set that equal to 0, and the cosine has to be negative 1/2. So you have a cosine of x is equal to negative 1/2. Right? So then we can find the angles that we're looking for. Let's do the sine equals 0. Right? So easiest way is just to look at the unit circle. So here's the unit circle, and here's the x-axis, and here's the y-axis, and here's the origin. Here's 1, 1, negative 1, negative 1. Right? So sine of x corresponds to the y coordinate of the point on the unit circle. So we want the y coordinate to be 0. Right? So y is 0, which means that along the x-axis, so either this point or that point. But that point only gives you the angle either 0 or 2 pi and bigger than that. So it's actually 0 and 2 pi are not included in the interval. So only point that we're looking for is going to be that guy. Right? So y value is 0. Right? Then you look at the angle that makes from the positive x-axis. So that angle right here is pi. Right? So this tells you that when x equals pi, sine of x equal to 0, which makes the derivative equal to 0. Right? And the other possibility is cosine is negative 1/2. So cosine corresponds to the x coordinate. So x coordinate, we want that to be negative 1/2. So we look for the point whose x coordinate is negative 1/2. right? Then you can see that we can think of 2 points here and there. Then we look at the angle that makes with the positive x-axis. So this is the angle, right? So this is a 30 degrees, a 60 degrees, 90 degree triangle. So this is 60, which means this is 120. So 120 is in radians is 2 pi over 3, right? And the other angle would be here. So again, this is 60 degrees, so it's a 180 plus 60 degrees would be 240. 240 in radians is 4 pi over 3, right? So therefore, you have a couple of values. X equals 2 pi over 3, and also 4 pi over 3, right? So therefore, the critical numbers that we are looking for are smallest one is 2 pi over 3, next one would be pi, and next one is 4 pi over 3, right? So those are the critical numbers, right? That's it. I hope that this was clear.